Hello friends, welcome to the next lecture of the JC eConnect series of online lectures. We are into module 4, design for shear. So in the previous lecture we have solved one example on web shear, and also using the VCW value we were able to find out the maximum UDL which the beam can support. Now let's move on to an example with flexure shear. So the cross section of a pre-stressed concrete beam is a symmetrical T-section with an overall depth of 1300 mm. The thickness of the web is 150 mm. Distance of the top and bottom fibers from the centroid are 545 mm and 755 mm respectively. At a particular section, the beam is subjected to an ultimate moment of 2130 kilonewton meter and a shear force of 237 kilonewton. Effective depth of the section is 110 mm, that is small d. The cube strength of concrete is 45 Newton per mm square, means this is the grade of concrete given which we required in the tau V calculation. Okay, so when we refer the table in IS code book, page number 33, table number 8, we need to use the grade of concrete. Okay, so cube strength means the grade of concrete. Here the grade is given as M45, or in terms of cube strength it is 45 Newton per mm square. Now effective pre-stress at extreme tensile phase of the beam, FCP. Okay, note down, this value will be very important in the solution. FCP is 19.3 Newton per mm square. Okay, so we need not find stress, directly it is given. The second moment of area, that is moment of inertia, I value is 665 into 10 raised to 8 mm raised to 4. Area of the steel AP is 2310 mm square. The tensile strength of the tendons FP, okay, tensile strength is 1500 Newton per mm square. Effective stress in the tendons after all the losses FPE. Okay, so previous one was FCP, that is pre-stress at the extreme tensile phase. Now this is effective stress in after the losses, FPE is equal to 890 Newton per mm square. Estimate the flexural shear resistance of the section using Indian or British code regulations. Okay, so Indian or British code regulation means both are same itself, hence in the example it is given like that. Okay, so again example has a bulk of given data which has to be noted down very much properly. Okay, note down the section of the dimensions, the dimensions of the section, excuse me. Further, note down the centroidal distance from top and bottom fiber. Moment value M is given at a section, and at the same section shear force value is also mentioned. Effective depth is given, so particularly note down that D value is given, or instead of giving D value they can give you the cover. So from the overall depth you have to subtract the cover to get the effective depth. Cube strength, that is the grade of concrete, is mentioned, and various other values which are required are given. So if you refer from page number 32 onwards, you will find design of shear. Okay, design of shear. Even before that, once you refer the code book, in the index itself you will find the title design of shear, where these all formulas which we used are given. So you need not worry much about the formula. What you have to take care of the given data, and you need to analyze what we have to find in the example. So in this example we have to estimate the flexural shear resistance, okay, of the section. We have to estimate what? Flexural shear resistance. So first let's go on to the formula. VCF is given by 1 minus 0.55 FPC upon FP. Both values are given, need not worry. Multiplied by tau C into BW into D. Here BW is known, D is known, small d, that is the effective depth, is known. We need to find Tc. So mark it. We need to find Tc plus m naught by m into V. So here we know the value of m and V. M naught needs to be found out. Again, the formula for m naught is mentioned in the code book. Need not worry about it. So m naught is given by 0.8 FCPI upon YB. Okay, so now here what is YB? Distance of the centroidal axis from the bottom fiber, which is given as 755. So substituting the values, 0.8 into 19.3 into 665 into 10 raised to 8 divided by 755 is equal to 136 into 10 raised to 7 Newton mm. So we get the value of m naught. So please see there I have mentioned equation 2, and in the previous lecture where we discussed the formulas, same equation 2 is mentioned. Now if you are working properly, by now you would have penned down these formulas. So when I use the formula here and when you are looking at the video keeping your reference book, you will directly realize which formula I am using. Else if you are looking at the videos blindly without referring the previous videos, you will not understand the contents. Okay, so it is very much important that the previous videos you have followed, so the next videos become easy. The previous video, first was that of the formulas, second was that of the example with web shear. Now this is the third one where I am analyzing flexural shear. Okay, so substituting, we have got the value of m naught as 136 into 10 raised to 7 Newton mm. Now only thing which we have to find out is tau c, that is the shear capacity of concrete. So now I think similar thing you have done in your RCC, that was table number 19. Okay, IS 456 page number 72, but here we are referring to table number 8 page number 33 of your code book. I think Professor Naresh Patil has already shared the code book with you all. Okay, please, if you have not got the code book, download it, it will be required. So now the first column, what is given is the percentage of reinforcement. So we will find it, AP is the given value 2310 divided by B into D, that is width into the effective depth, multiplied by 100. So we get a percentage of 1.4. That means we have to search a value of tau c which lies in the range of, when we look at the column, we have a range of 1, 1.25, 1.5. So our 1.4 lies in between 1.25 and 1.5. Okay, so again we have to use interpolation, and by this 8th semester level, interpolation should be very much easy for you all. Okay, don't expect interpolation to be taught to you all at this point of time. So looking at the top column titles, we have grade M30, M35 and M40 and above. Okay, so our grade was M45, so we'll be using the last column. One more hint you get from here is, for PSC, minimum grade of concrete we require is what? M30. Below that we don't go for PSC. It may not be defined anywhere, but this chart or this table gives you a clear indication that when we are checking for shear, the minimum grade which is there is M30. Okay, so always remember, if you further go on sites or wherever, if you come across these things, minimum criteria is M30, which is required for PSC. Okay, so let's use the values of the last column, that is M40 and above, which are 0.74 and 0.79, corresponding to 1.25 and 1.5. So by interpolation we get tau c for a percentage of steel of 1.4 as 0.77. So now in the previous formula, all the values which we require we have obtained. That is the formula for VCF. M0 we have obtained, as well as tau c we have obtained. Other data is given. Okay, so let's substitute all the values. So in calculation, be careful because it becomes a big equation. Substituting all the required values, we get 240 as the answer for VCF. Okay, so in the given example, along with moment, shear at the section is also mentioned. That is what 237 kilonewton is the mentioned shear. So now what we can conclude, our VCF value has come as 240. Therefore, the actual shear 237 kilonewton is less than the ultimate shear resistance of the section. So here when we go for design, only will require minimum shear reinforcement. So now see the catch in the example. 237 was given. We are not using that value anywhere till the last conclusion point. In the example, what was asked? To find the ultimate shear resistance, which we found out as 240. But where that value of 237 we have to use? Okay, so actually technically once you find the 240 value, example is over. Then for what is 237 given? Okay, so that last step or the last conclusion statement or remark may carry 1 or 2 mark. Here the examiner wants to check whether you are aware that one V value is given to you all and how you use it in the example, because in the formula it is nowhere there. We calculated ultimate shear resistance, we got the answer as what? 240, but already along with the moment, what was given? Shear force at that section V is equal to 237 was given. So our section can resist shear up to what limit? 240 kilonewton. Okay, and given value was how much? 237 kilonewton. Hence it is safe in shear and minimum shear reinforcement will be required is the conclusion. Now what is that minimum shear reinforcement? Okay, and if it is not safe in shear, what is to be done? We will be studying in the next part of the examples. Okay, so up to here we are concluding with analysis examples. The starting videos were of simple shear analysis. Okay, then in the second part I can say we have covered the formulas for web shear and flexural shear and then solved one example on each. So at this point we conclude with the analysis example. Now from next class onwards we will be studying the design examples where application of this analysis examples comes in. So again, if you start with directly the design of shear examples, you don't know which table to refer, how to refer, which are the formulas to be referred, because we will come up to this point, then we will conclude whether we have to design shear reinforcement or no, and then go ahead with the examples. So in exam, if you get analysis examples on shear, you will be damn lucky because they will be direct formula examples. Formula you can take from the code book, substitute and solve. Design examples are a bit tricky but not that difficult also. But if you are perfect with the analysis example, it will help you all to solve the design examples. Hope you are making the notes properly, and this all syllabus up to I think shear, flexure and shear both will be there for your internals. Okay, second online internals. So please keep up with the syllabus. Thank you.